Okay, so I welcome you all in the session of fluid mechanics lecture number 6. So this is going to be our last lecture for fluid in motion. Before that, we have studied fluid in static. Okay, so after that, in tomorrow's class, we are going to learn about surface tension and surface energy. So firstly, we will deal what we have to learn today. Okay. So today we are going to see viscosity, and we are focusing on this topic also because it is a very important topic. So I have chosen this one. Although ये बात सोच करके खुश मत हो जाना कि ओहो this is one topic only, so we have to study only viscosity. No, viscosity itself is a chapter. Okay, now मेरा गला थोड़ा खराब है तो आपको हाय वीरेंद्र, हाउ आर यू? गला खराब होने की वजह से देयर इज अ प्रॉब्लम इन थ्रोट, so you will hearing a sound of cough, so avoid that. Only focus on my beautiful voice that I have got. Okay, so viscosity we are going to discuss today in viscosity. So I welcome you, Virendra, a student from JNV Baleri. I welcome you all. Attend this session, increase your learning, increase your understanding of physics. Okay, so today's learning objective is viscosity and coefficient of viscosity. Okay, Stokes law and terminal velocity. Yeah, that is it. These two topics we have to learn. Now, I will play a video in front of you. Okay, enjoy this video and try to predict what is happening. Look at the video. What is happening? He or she, whatever he is, I think she. So she is putting some balls in the jar, which is filled out with a different liquid. And you will see when you put the ball in the very first container, the ball will drop instantly. And now if you will see in this pot, it is going very slowly. And this pot also, in this also, it is going very slowly. Now, why it is happening? So there is some kind of mystery there. Mysterious force is there, which is stopping this ball or restricting the motion of this ball. Once again, yeah, we will play it once again. Don't worry. इसी के लिए तो हूं मैं यहाँ. We will play it once again. See, and it is also filled with liquid. I think it is water. Okay. Hi Bharat, how are you? देखा इस वीडियो में? Look how instantly it falls in this. But if you talk about this container, focus on that. Look how slowly it is going down. How slowly. Which means there is something which is reducing its velocity, its speed in the liquid, inside the liquid, and that is present inside the liquid. We have applied no external force. Okay, so this is something which is inside the liquid, and you can say in this the speed is high. If you will see, it is in this speed is high and the speed is low. Who is the factor who can reduce the velocity? Acceleration. If you apply the deceleration or acceleration in opposite direction to the velocity, it will decrease the velocity. Velocity is decreased by acceleration. And who is going to produce this acceleration? Newton says that this acceleration would come because of a force. So liquid is applying some kind of, or this fluid, I will say, applying some kind of force that is reducing the velocity of a ball, which is covering the distance inside the liquid, which is falling in the liquid. Now, what is this mysterious force is called? This mysterious force is called viscosity. This is the viscosity. Got it? And it is acting same like the frictional force. What does the friction do? Friction will oppose the relative motion. So it is also opposing the motion. So this is the frictional force, but provided by liquid or fluid, you will say. That is why it is termed as viscosity. Now, focus on the definition. Viscosity is defined as the internal resistance. Focus on this line. It is the internal resistance offered by a layer of fluid to the adjacent layer by layer. Now, what is happening? I will give a hint. I will give the whole concept to you. This is the surface, let's say. This is a surface. Okay. Now, the fluid is flowing above this surface. You can consider it to be a pipe. Okay. And we are not considering this cross section. Only the bottom side layer we are interested in. So we are taking that. So what will happen if you zoom this surface? It has nulls and void. This is not a proper surface. It is a rough surface. So because of that, the water which is flowing, or I will take the example of water here. So water that is flowing through this, it is made contact with the surface and it has null and void. So for water molecule, this will act as a barrier. The water will strike to this and lose momentum, which means reduces the velocity. If the layer which is adjacent to the liquid decrease its velocity due to the continuous collision with the null and void, with these voids, peaks and valleys, the roughness. So this has a lower velocity and the layer just above it. It is moving with a velocity, let's say 10 meter per second, and it is also moving with a 10 meter per second, but now it has reduced because it has made contact with this. So what will happen? It has now 5 meter per second velocity. So there is a difference in velocity. Difference in velocity cause the momentum decrease. So these layer are just adjacent, एक दूसरे के साथ बिल्कुल चिपके हुए हैं. Okay, so this layer will pull this layer in the opposite direction, which means the layer by layer, the each layer pull the layer which is above that one. Got it? So it is a continuous reduction in the velocity of the layer, because we know that in streamline flow we have discussed that liquid flow layer by layer. So each layer, look at this, each layer rubbing on each other, and this is slow, and this is moving fast. So this will try to reduce the velocity of it because of the resistance offered. Got it? So that is why the viscosity arises here. This is a frictional force. This is nothing but the frictional force. Frictional force provided by the liquid. Now, you can say that if it is a frictional force, then why we are saying it a viscosity? Why we are increasing the number of terms or the names? Why don't we exactly say it frictional force as we have did in the Newton laws of motion? Because suppose there is a jungle, and in a jungle there are hundreds of animals, and one of the animal has a name of, let's say, peacock. Okay. So if you name each and every single entity of this jungle as peacock, then it is very hard to identify. Okay, let's say the lion has killed some of the entity, then who will bear the punishment? Peacock, because there is no name. Lion exists there. All the names are peacock. So who is going to bear the punishment? Peacock only. So that is why we have to name the different terms. Because although it is a frictional force, but it is offered by a liquid, so we have to suggest a different name of that. We are suggesting it a viscous force, and the phenomena of this providing frictional force by the layers of liquid is called viscosity. I hope you are clear with this now. Everybody, any kind of doubt, any point of time you can ask. Do not wait for me to ask ki you have a doubt, then ask. No. If you have, then ask. Okay, so now you understand, I think, the concept of the adjacent layer friction. Yes. During the fluid flow. In static condition, when the fluid will flow or anything inside the fluid will flow, then the viscous force arises. In the same way, when you move, then only the friction force by the surface of earth will act on you. Na? If you are not moving, the friction force is not acting. Okay. Now, this. So this AD is the layer which is in the contact, and this also a layer which is in contact. This is the liquid I have taken, liquid diagram of particular instant. So the velocity of this layer, let's say AD, will be zero because it has made contact with the surface, and because of this peaks and valleys strike the water strike lose momentum and has become a zero velocity member. So here the velocity is zero. Let's say the magnitude of velocity is represented by these lines. So as you move up, the speed will increase, because let's say here the velocity is zero and the whole liquid is moving with a velocity of 10 meter per second. So the adjacent layer has non-zero velocity, let's say 2 meter per second. इससे ऊपर v is equals to 5 meter per second. Okay, फिर 7 and ऐसे ही 10. So as you move in the direction of this length, so velocity will increase. Okay, so this is a kind of situation with shear force. In shear force, what is happening? I think this ink is visible to you. What is the concept of shear force? Shear force may we have applied the force parallel to the surface. This is F for shear, so that it will disturb the shape of it by angle theta, and this layer is fixed. The same is happening, the same thing is happening with fluid also. The fluid layer which is adjacent, let me change the color, which is adjacent to the surface has a velocity zero, which means it is a fixed layer. And the upper layer, the adjacent layers of liquid exerting a force. In which direction? This layer want to pull this layer in the opposite direction, in this direction. So these layers are applying force in the parallel direction to the surface or to the layer. So the force we will have here is also kind of shear force. Got it? So that is why this viscosity, I will discuss it in next. So these are the two glass plate, and this is the liquid film inside it. And these are the two plates of, or you can say this is pipe, cross section of pipe, and this is the liquid flow. You can easily understand that why at the middle the velocity is high because this layer is also in contact surface. So here the velocity will zero and then it will increase. Here also it is in contact with this layer. So velocity will zero here. As you move up, the velocity will increase. Okay, got it? Now, coefficient of viscosity, eta. So the coefficient of viscosity for a fluid is nothing but the ratio of the shearing stress to the strain rate. Shear strain rate, not the strain only. It is a strain rate. Okay, because experimentally it has been observed that the value of force is not depend on the strain. It depends on the rate of strain. So that is why for defining the coefficient of viscosity, we are taking the ratio of shearing stress to the strain rate, not the strain also. Okay. So to calculate this, we will consider this situation. Let's say in delta t time, the liquid has displaced v into delta t, because if the velocity is v, delta x upon delta t. So delta should be v into delta t. Got it? This is not a rocket science. You can easily conclude that. Now, eta is nothing but shearing strain to the strain rate. So it is F upon A. Shear stress is force upon area which is parallel area will take, divided by the strain rate. Strain is change of this angle, shear strain, and let's say this angle is phi. So delta phi by delta t. This is important. This is strain rate, not strain itself. This is a strain rate. So delta phi you can say is equals to, if you take this as phi, this as delta x. So this angle, let's say this is delta phi. So if you apply the tan delta phi, what it will become? Tan delta phi is equals to this perpendicular over base. Perpendicular is nothing but delta x. Delta x divided by delta, delta x by L. Now, this delta phi is very, very small. So we will take this tan delta phi as delta phi. So delta phi will become delta x over L. Now, put the value of delta x in terms of v delta t. So what it will become? Delta phi by delta t, delta x by delta t into L. We have divided this expression with delta t. Now delta x by delta t is nothing but the velocity with which the liquid is moving. So v by L. So strain rate we have as velocity divided by length. Now this is also called the velocity gradient, because if you measure any physical quantity with respect to the length, then it is called as the pressure gradient. Sorry, gradient of that physical quantity. Got it? Now, I have also discussed this in gravitation when we have discussed the potential gradient. है ना? Now, eta will be shearing stress by shearing strain rate, F upon A upon V upon L. This is called the coefficient of viscosity and represented by eta. This is eta. I will write it here in Hindi. So it is eta. Got it? Now, unit is very important for it. Okay? So try to note these units, because one of the question is directly asking from the units or the dimensional formula of it. So in Newton per in MKS system, meter, kilogram and second, MKS system, generally it is SI system also. So Newton second per meter square or Pascal per second. Why Pascal? Because Newton per meter square is nothing but Pascal. So it is Pascal second in MKS or Newton second per meter square. Got it? Now, in CGS unit, it is termed as Poisson. क्या है ये? poisole. Yeah, I understand the name are so heavy. Why what we can do that? Okay. What we can do about it? We have to learn this. So this is poisole in CGS. So for easiness, you can also call this only poise. Okay. So 1 Pascal second or 1 Newton second per meter square is equals to 1 by 10 of poise. So you can say that 1 poise, Poise, is equals to 10 Newton second per meter square, or 1 poise is also equals to 10 Pascal second. Okay, this is important. Poise. What is the dimensional formula of it? M L raised to the power minus 1 into T raised to the power minus 1. Now, ready for the challenge? I hope you are ready for this challenge. Got it? You have to do this challenge. Now, water flows between two plates, of which of the lower one is stationary and upper one is moving with a velocity v. Now, what will be the velocity of fluid in contact with the upper plate? Now, सोचो इस बारे में. Water flows between two plates of which lower one is stationary. ये दो प्लेट है हमारे पास. These two plates we have. And water is flowing in between these plates, in which one of the plate is stationary. This plate has a zero velocity. Now, and the upper one is moving with a velocity v. This is also moving with a velocity v. Now, what will be the velocity of the fluid in contact with the upper plate? Yeah, because it is stationary. So this layer will strike to the peaks and valley. So velocity will become here 0. But for that, this plate has to be stationary. And it is given in the question that it is stationary. But this plate is not moving, is not stationary. It is moving with some velocity. Some of the student has answered it. Let me check. So JNV Ramnagar student has said that V4 is equals to 0 for upper plate also. So let me see. We will see it. So in this situation, we will discuss one term which is no slip condition. No slip condition says that the relative velocity between the plates and the fluid in contact with it must be 0. Okay. But the relative velocity, got it? So this is the no slip condition, which means there is no slipping happening between the plate and the adjacent layer of fluid. And it is obvious because fluid will lose all of its energy when it made the contact with the layer. So the velocity of the fluid in contact has a velocity 0. Okay. Now, these are the two layers. This is the liquid we have filled. This is fixed and this is moving, okay, with certain velocity. Now what will happen? This will shift as like this because this layer is not moving, but this is moving. And also this plate is also moving. So what will happen here? According to no slip condition, what is the condition? That the relative velocity between plate and the liquid is 0. Okay. So, and the upper layer is moving with V. Look at the question. Lower plate is not moving. Upper plate is moving with velocity v. And we know that to make the contact with liquid, there is no slip condition, which means the relative velocity between the contact layer and the contact is 0. So if the contact is itself moving with a velocity v, so to make the relative velocity 0, what should be the velocity of the contact layer? Let me take the numerical value in it. This is fixed, so velocity will become here 0. The upper plate प्लेट के बारे में बात कर रहा हूं. वेलोसिटी ऑफ प्लेट इज 10 मीटर पर सेकेंड, लेट्स से. Okay, so we know that when this layer make contact with this plate, so the relative velocity will become zero. So v relative यानी कि velocity of fluid with respect to plate is equals to zero. Now we know that velocity of fluid with respect to plate is nothing but velocity of fluid minus velocity of plate. So if velocity of plate is 10, which is given, I have assumed that it is 10 meter per second. So make this relative velocity zero. What should be the velocity of fluid at the contact of it? It will be 10 meter per second. Got it? Same velocity we have to acquire, because here the plate is also in motion. And to make the relative velocity zero, we have to flow the liquid, or the liquid has to be flow with the same velocity of plate, which is v. Got it? So I hope you got the difference, JNV Ramnagar student. You are not fully wrong, you are partially correct. Okay. Yeah, this layer has a velocity 0, but this layer has a velocity v. Got it? Got it? Okay. Everyone, Virendra, student of JNV Medak, Bharat GS. Yeah. Okay. Fine. And let me ask you one thing in this. If the velocity of this is v by 2, so what should be the velocity of the fluid? Batao. What should be the velocity of fluid? If the plate is moving with v by 2, what is the velocity of fluid? Tell me. Make it quick. Very good. Very good, student of JNV Ramnagara. You are cracking JEE mains. Okay, so v by 2 is the answer. All agree with that? JNV Medak, Virendra, Bharat. What about you guys? Okay. So Virendra is the student of JNV Baleria, no? Got it. Now, again, this is a question. The space between two plates, 20 centimeter, 20 centimeter, and 1 centimeter, is the dimension of the plate. Okay, this is 20 centimeter. This obviously with the 1 centimeter, and the rest of it, which is not shown to you, is this. This is the plate, na? 3D. So this length is also 20 centimeter. Okay. A part is filled with a liquid of viscosity 1 poise. 1 poise means 10 Newton per second. Sorry, 10 Newton second per meter square. Now, the upper plate is dragged to the right with a force of 5 Newton, keeping the lower plate stationary. What will be the velocity at the middle of the plate? At the middle of the plate. So, let's get it. So these are the dimension that is given to you. Force applied is given to you. Area you can also calculate. And because of that, with the help of this force and area, this is acting on this area, which is in the contact. This 20 into this 20. Okay. This is making contact with the, this is the plate, na? So this lower area is making contact with the liquid. The force is applied on this area. Okay. Because of that, we are able to find out the shearing stress by shearing strain, which is the formula of coefficient of viscosity. Shear stress is nothing but F by A into V by A. L we will take, that is given to us 0.5 tak we have to apply. So it is 5 upon, dekho, here the area it has taken as 20 into 20, 10 raised to the power minus 4. Got it? The area which is below it, this much, 20 into 20. Okay. 5 is the force applied. V is the velocity that we have to find out up to which length? at L by 2, which is 0.5, because this separation that we have taken is L. So this will become L by 2. We will take this L as L by 2, which is 0.5 into 10 raised to the power minus 2. Got it? We have to convert this centimeter into meter. So the velocity will become 6.25 meter per second. Got it? Easy one. Huh? Any kind of doubt you can ask. Now, the next topic of the today's class is Stokes law and terminal velocity. Got it? Now, what is Stokes law? So Stokes law, Stokes, which is a famous scientist, has related the force that a ball or any material will experience when it falls in a liquid having a viscosity. Like we have seen in the very beginning of this lecture, we have seen a video. In that video, that particular lady has dropped some ball in different containers filled with different kind of different liquid with different viscosity. So in that video, you have seen that these balls are not traveling with the same speed. The speed of travel is different. The more viscous the fluid is, the less will be the velocity. Look, for example, what is easier for you guys? What is easier for you? If you put your hand in a tub which is filled with water, so you can easily rotate your hand, easily pass through it. Although you will feel some kind of force, that is the viscous force, but it is easy for you. Now, if I fill this tub with honey, so will the same force will be applied to you, or you have to apply more force to drag into that liquid? Tell me, more force or less force? If you drag your hand in the bucket or in the tub of water and in the tub of honey, so in, let's say, in the water it is case A and in honey it is case B. So in which case you will feel more force, or you have to apply more force? In which of the cases? In case A or in case B? Tell me. Very good. In case of honey, we have to apply more force to drag through it, because honey is more viscous than water. More viscous means more viscosity. Very good. Student are of JNV Ramnagra and JNV Medak. Very good, guys. Got it. So Stokes is a scientist. He has a spark in his brain, and he relate the viscosity with this force and forms a law which is called as Stokes law. So Stokes law says that when a body falls through a fluid, it drags the layer of fluid in contact with it, because whenever the body will fall through a liquid, it will making a contact with the layers of that liquid, and the layer will drag it, and that is why the retarding force has been formed. Okay, so these different layers of the fluid is set, and a result of this situation, the body will experience a retarding force on it, which is known as viscous force. Now, this viscous force, let's say Fv, is directly proportional to, and this has been observed by experimentally. Okay, this, the observation of this law is made purely on experimental basis. So it is directly depend on the radius of the sphere. Let's say this is a ball, and it is also depends on the coefficient of viscosity of that fluid, and it is also depends on the velocity with which the fluid is the object is traveling. So if you combine all of that, the force is directly proportional to eta rv. And to remove this proportionality sign, experimentally the constant will come is 6 pi eta r v, and it is minus because it is retarding in nature. Okay, so this is simple as the Stokes law. Stokes law says that as the velocity increases, the viscous force increase, which means if you are traveling in a viscous fluid with more velocity, the more drag force you will feel. And it is not in the case of liquid, it is true for the case of gases also, because this phenomena, that viscosity we are discussing, is valid for fluid, and gas is also a fluid. And you have observed this whenever you have traveling with your mummy and papa in your car, scooter, bicycle, whatever the equipment you have, and when you accelerate that, you will feel more air coming towards your face, the more drag होता है ना ऐसा, the more air will resist you because you have increased your velocity. So the viscosity, because air is also a fluid, it will also offer some viscous force to you. The viscosity of air, or the viscous force of the air, will increase. So that is why you have, the engine will burn more petrol, use more diesels, or if you are running an EV, electric vehicle, so it will consume more electricity, because engine will have to apply more power to drag through this liquid, drag through this fluid, I will say. Got it? And that is where the aerodynamics has come. That is why we have discussing the aerodynamics. We are not discussing, but in engineering we will discuss the aerodynamics of structure of the vehicle, aeroplane. That is why we are more interested in the shape of the particular vehicle that is going to move on the road, on the air. You have observed that the jet air that we have developed, they have a very sharp needle type of structure at the beginning, this type, and this is the another. Why is this? Because it can easily penetrate into the liquid, into the fluid. Got it? Because this pin, this point, has lesser radius. So if radius would decrease, the viscous force will also decrease. So that is why we have made these fighter jet with the needle type of structure, sharper edge. So this is the phenomena. The gravitation force would try to grab it in the downward direction, but due to the viscosity of fluid, it will apply a drag force to this ball. Okay, and this force is given by 6 pi eta rv, and it is minus, and minus here indicate, minus sign indicates the that it is a retarding force, retarding force. Got it? Where Fd is the viscous drag force, eta is the coefficient of viscosity, r is the radius of spherical ball. These are the bachcho wali terms, so I will not think you have to introduce that what is viscosity. We have already discussed it now. And v is the obviously velocity of the ball. Okay. Now do this question. What happens to the drag force on the sphere if radius is increased by 50%? Obviously we will say, we will have an idea that the drag force, the viscous force that we are talking about, is 6 pi eta rv. So it is depending directly to the radius. If radius will increase, the force will increase. So here we have increased the radius by 50%, which means r by 2. 50% of r will be r by 2. So now the new radius will become r plus r by 2. So it will be 3r by 2. The force will become 6 pi eta r v r dash v. So f dash is equals to 6 pi eta r dash की value 3 by 2 r into v. So it will become f dash is equals to 1.5 times of f. Okay. So we will see it in a more detailed way. One of the student has answered it, and let me check the answer. Okay, JNV major student has said it is increased by 50%. We have also seen it. The radius would become 1.5%. So it's a simple relation we have. So the force will also become 1.5%. I have discussed it, the solution. So it is not 50% directly. It has been increased by 1.5%. Because JNV made a student focus on that. What I'm saying now, the force is not dependent on the change in the radius. It is dependent on the radius itself. Okay, you have seen कि increased is 50%. That is the change of radius, na? So that you have directly related. Force is directly proportional to r. Force is not directly proportional to delta r here. It is proportional to r, which means you have to calculate the final radius. Okay. So I hope everyone is getting this. Now moving on. Again, a small spherical ball. Thank you so much guys for your response यार. खुशी कर दिया आज तो आपने. A small spherical ball falling in a viscous fluid attains a constant speed after some time. Why? जैसे ही आप किसी viscous fluid में, you have take a viscous fluid, you drop the metallic ball into that. Initially it will accelerate, but as it move downer and downer, it will become a constant velocity profile. Constant velocity से move करना start कर देगी. How it is possible and why it is possible? Look, I will tell you the whole story behind it. This is the container in which a viscous fluid is filled. Red fluid hai, it is a very denser fluid, so do not try to drink it. Yeah, very good, because of viscosity. But viscosity is only applying 6 pi eta RV. We have to give in a proper reason. And very good. Who is this? Just a second. Okay, JNV Medak student. Very good approach. Try to think more on this. This is the metallic ball, let's say. Initially, it has a velocity v. And here, it has a velocity, let's say v dash. Now, what is happening? Initially, when you drop this, there is a buoyant force also. भूले तो नहीं ना? Buoyant force has come. Buoyant force is also applied by a fluid, FB, which is also a kind of resistance force. Frictional force or viscous force, Virendra? Yeah, definitely. Because of viscous force developing in that. No. Initially, you just drop that, let's say. So initially, if you are dropping, the velocity is 0. Viscous force says that I am equals to 6 pi eta RV. But V is 0. So there is no viscosity. There is no viscous force. But initially, the buoyant force will apply. And let's say the density of this object, this metal object is rho, and density, let's say the density of it is sigma, and density of the liquid is rho, because we are assuming the density of fluid as rho. So here we also take the same. So initially we assume that the density of this object that we have dropped in the liquid is greater than the density of liquid. So what will happen? The buoyant force is not sufficient to hold this. It will go downer and downer. As it is going down, because there is a net external force, the weight will act downward. So on this ball, there is a buoyant force initially. Initially, if I talk about, Initially, there is a buoyant force and there is a weight of this ball. Okay. So the net resultant force will be in this direction because buoyant force is less and weight is more. So what will happen? There is an external force. So there will be an acceleration. So initially it will accelerate. Now it has gained some velocity because of the acceleration. So when it goes get the velocity, let's say v at this particular point of time. So viscous force will also come 6 pi eta rv. ऐसा होता है ना फिल्मों में एकदम से कुछ सब हो जाता है. So the viscous force is that kind of factor. Okay. Wait. I am viscous force. I am also here. Don't forget me. So viscous force is also here and it is also kind of resistive force. So it will in final condition, what will happen? This is the ball that is going very peacefully. Okay, once more I will discuss it. Let me finish with this. So what is happening? Initially, you just drop the ball. The velocity of the ball is zero, which is very initial condition. Velocity of the ball is zero, and the viscous force is 6 pi eta rv. If there is no velocity, there is no viscous force. Only buoyant force is there because it does not depend on the velocity. It depends on the density of the material. Okay. So buoyant force is density of liquid, volume immersed, and into gravity. Now density of this liquid is less than the density of this material. तो अगर मैं पानी में एक लोहे की बॉल डाल दूं तो what will happen? It will sink. Got it? Same thing will happen here. It will sink and it will move down with an acceleration. And why this acceleration has come? Because buoyant force is not sufficient to hold this ball. So the weight will be the dominating factor here. So weight minus FB, there is a resultant force here. F resultant will be F buoyant minus weight. So if there is a force, there will be an acceleration. Got it? If there is an acceleration, there must be the development of velocity. Or velocity will develop slowly. धीरे धीरे velocity develop होना शुरू होगी. So when the velocity has developed, the viscous force will come into contrast because it is 6 pi eta rv. सब कुछ था इसके पास, 6 भी था, पाई भी था, eta भी था, radius भी थी, only velocity is not there and now it has come. So viscous force is also introduced and viscous force will also try to oppose the motion of it because it is the friction force. So this is Fv and one force is more, buoyant force will also there. इसी का भाई आ गया साथ में. Now they both will act upward and the weight is acting downward. So this buoyant force and this viscous force try to pull this ball up and the weight will pulling it down. Now the velocity will keep increasing because there is an acceleration. At certain point of time, the velocity will increase so that the viscous force and the buoyant force will balance the weight. This is going to happen at certain point of time, na? Initially, let the weight is 100 Newton. Okay. And initially there is no viscous force, only buoyant force is there, and let's say buoyant force is 20 Newton. So there is a 80 Newton force in the downward direction. As the ball will move down, it will gain velocity. The viscous force will also there. So viscous force, let's say initially at some time, it is 50 Newton. So 50 plus 20, 70, not sufficient. The ball will move down. Then it will increase because velocity will increase. Then it will become 80 Newton. So 80 Newton plus 20 Newton is 100 Newton. And downward direction is also 100 Newton. Now, there is no net force. If there is no net force, the ball, there is no acceleration. If there is no acceleration, the ball will move with the constant velocity then. Okay, the ball will move with constant velocity. Got it? And that velocity is the maximum velocity that a ball or any material can achieve inside a fluid. उससे ज्यादा तो नहीं हो सकता. So that is why this velocity is called as terminal velocity. Got it? I hope you are clear with this. So student, are you clear with this? What I'm saying? Student of, yeah. So it is clear for Virendra. What about JNV Medak? JNV Ramnagar has also replied. Okay. So reason for that I have already told you in a very detailed way. Now, this is a very simple question, so we are not going to discuss it. Although you can note it down if you want to take a screenshot of that. Now, terminal velocity. So this I have discussed this thing obviously, but initially there is an air, the ball is moving downward. So air will apply a drag force to that, and it is moving with the help of gravity. Gravity is exerting a pull force on that. Okay. So terminal velocity is the maximum velocity attainable by an object which is falls through a fluid, because fluid will exert Fv and Fb in the upward direction, and the weight of the object will act downward. This Fv is variable, so it will constantly increasing its value, and when the summation of that will equals to the summation of this, the ball will feel no force in that condition, no external force acting on the ball. In that case, the velocity that is achieved by the body is the maximum velocity attainable and is called as terminal velocity. Now, we will also derive, you can see this video. जैसे जैसे बॉल की स्पीड बढ़ रही है, एयर रेसिस्टेंस विल इंक्रीज. Air resistance is viscosity or viscous force by air. Okay. And this will attain, देखो, this vector has same length as this vector. Now this has nullified the effect of weight. And this is the condition where the velocity of this ball will become terminal velocity. Okay. Now, derivation, very easy, very simple. This is the ball we have taken. Let's say the density of this ball, which is made of some kind of material, is rho s, solid, and the density of the liquid is rho l. The weight which is acting downward, it is rho s g into v. I have already told you in fluid mechanics, we will not take weight as mg, we will take it as rho vg. Okay. So rho of solid, gravitational acceleration multiplied by the volume. Now, this is the FB, which is acting in the upward direction. It is FB is it is not, I think, clear to you. It is rho of liquid, volume of solid which is immersed, complete volume is immersed. So I have taken it is V into G. So rho L into V into G. And there is also one of the force which is 6 pi eta RV. Okay, this is the viscous force. So at equilibrium, what will happen? The force due to gravity, which is weight of this body, equals the resultant force of buoyancy and viscosity. Got it? It equalizes this force, the buoyant force and the viscous force. We will put the values of these forces, and what do we have? 6 pi eta RV. We will take this term here, and we will take this term this side, so it will become minus. Taking G and V as common, it will become rho s minus rho L into G into V. Now, the volume of this sphere is nothing but 4 by 3 pi r cube. We have to do this now. So V here is nothing but we will derive this. We will take this term in this side. So this will become 2 by 9 eta rho of solid minus rho of liquid r square g. This is the velocity of this ball. And you will see that this velocity is not a variable velocity. The radius is constant, g is constant, densities of the both solid and liquid is constant. Eta is also constant, and 2 by 9 obviously it is a constant. So it is a constant velocity. And you can also say that this velocity is the terminal velocity or the maximum velocity. Got it? Now you can easily answer this question. A small metal sphere is dropped through honey and another identical sphere is dropped into a less viscous oil. Comment on terminal velocity. From the example, for this formula, you can say that this velocity is inversely proportional to viscous force, viscosity. As the viscosity increases, the velocity will decrease. So in honey, the viscosity of honey, let's say eta h, and the viscosity of oil is, let's say, O. So viscosity of honey is higher than this. So velocity will follow the inverse relation of that. Got it? Now this is it from my side. Thank you so much for being attentive. If you have any kind of doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive. And yeah, keep studying and take care of yourself.